This video serves as a very brief introductory overview of scientific notation. I will do a few examples, so you may wish to have a paper and something to write with. Although for more detailed examples, you'll want to see Canvas for more information or other videos linked on YouTube. Scientific notation is a system for expressing very large or very small numbers in a compact manner. And there is three components, I guess, for a number written in scientific notation. The first is this coefficient. This is the number, and it will always range from 1 to 9.999. So it has to be less than 10 and greater and 1 or greater or less than 10. And then it is multiplied by the base 10 raised to some power. And this scientific notation is based in base 10 because that's what we use, that's what the metric system is based in, and it's our number system that we count in base 10. So it's always going to be a number raised to some power of multiplied by some power of 10. What does it mean when we say a power of 10? It just means 10 raised to some exponent. So if you look at the powers of 10, the positive ones, this number here, the number that the exponent that 10 is raised to, that is the number of zeros. So 10 to the 1, there's 1 0. 10 to the 2, there's 2 zeros. 10 to the 3, there's 3 zeros. And so we're really just saying 10, 10 squared, 10 cubed, 10 to the 4th, etc. For negative powers of 10, we are moving the decimal place to the left. So 10 to the negative 1 is 1 over 10. So it's 1/10. And so you get 0.1. And so this number tells you how many decimal places you have to move to the left. And so here we're at 10 to the minus 2, 0.01. 10 to the minus 3, 0.001. So this is 1/10, 1/100th, 1/1000th, etc. So if we wanted to express a number in scientific notation, here we have our 1,250,000, and we need to put our coefficient multiplied by 10 to some power. So let's figure out what our coefficient will be and what our n will be. So if we look here, we know that our number has to be between 1 and 10. So what that means is we're going to put the decimal point right here. So it's going to be 1.25, and then we have to figure out how many powers of 10 we'd have to raise it in order to get this whole number. So if we count, we see that there's 1, 2, 3, 4, 5, 6. And so we get 1.25 times 10 to the 6th. Now for this number here, same idea. The coefficient has to be from 1 to less than 10. So it's going to be 2.33. And we know that we're going to have to move the decimal place. We have to count how many times we have to move it to get to 2.33. So we move it 1, 2, 3, 4, 5. And so it would be 2.33. And then since we moved the decimal point to the right, it's to a negative power. And so it's 2.33 times 10 to the negative 5th. So now if you'd like to practice this on your own, I suggest you pause the video and then you can come back and look at it. So expressing 240,000 in scientific notation, we know that we're going to have a positive exponent because the number is greater than 1. And we know that 2.4 is going to be our coefficient. And we get 2.4 times 10 to the 5th. And then for this number here, we know that our coefficient is going to be 3.5. And then we count how many times we move the decimal place to the right. And because we have to move the decimal place to the right and this number is less than 1, we know it's a negative coefficient. So we get 3.5 times 10 to the negative third. Okay, now we can go the other way. We can express a number in standard notation. And so this number here, 3.4 times 10 to the minus sixth. So really what this is really simple to do, because if you have a negative 6 here, it just means move the decimal place 6 spaces to the left. So you're going to move it 1 space, 2, 3, 4, 5, 6. So if you want to think about a slightly easier way to do that, you can write it out each time if you want. That is completely fine. But we know that we're going to move it 1 space to the left, and then we're going to have 0.34. And then now we have 5 zeros to add. So it's going to be 0.5 zeros, 34. And now if we want to express 7.91 times 10 to the fourth, we're just going to move this decimal place 4 spaces to the right. 1, 2, 3, 4. And so we have to add 2 zeros to this number. So we get 79,100. Okay, if you'd like to practice on your own, you can pause the video here. So we can see this is a negative exponent, and so we're going to move our decimal place to the left. And so 1, 2, 3, so we're going to have 0.0012. And then 4.11 times 10 to the 1. Don't let this 1 confuse you. It's just 10. 4.11 times 10, so we just move it 1 space, and so we get 41.1. So now I want to talk briefly about prefixes. We use these in the metric system as a way to express basic and derived units if you don't want to use scientific notation all the time. So, for example, a centi is the prefix. If you're talking about like a centimeter, it's 1/100th of the basic unit. So you could write 1 times 10 to the minus 2 meters, or you could write 1 centimeter. And we will practice with this a bit, but I want to go over a little bit of tricks on how to do this. So practicing with these prefixes. These are the common ones that you're going to see. I will give you this memory aid on quizzes and exams. So you do need to know what they stand for, but you don't need to memorize all of the words there or all of the symbols. And so I want to go over what these mean. So we've got mega, kilo, deci, centi, milli, micro, and that this Greek letter, it's the Greek letter mu, and we use that for micro because milli is a little m and mega is a big M, and so we have to have a different symbol. So it's the Greek letter mu. And then we have a nano and pico. Okay, so let's work with centimeter because that one's pretty common. So 1 centimeter, you know that centimeter is 10 to the negative 2 meters. So if we have something that we want to convert between meters and centimeters, let's say we have 0.0031 meters. There's an easy way to do this. We can move our decimal place to the right. 1, 2. So we're going to move it 2 to the right. So 0.0031 meters is 0.31 centimeters. What if we wanted to write this number between 1 and 10 though? Well, we could use millimeter. 1 millimeter is 10 to the minus 3 meters. And so we take our 0.0031 and we move our decimal point 3 to the right. 1, 2, 3. and we get 3.1 millimeters. So we could easily express this here in scientific notation if we wanted to for meters. We could write it as 3.1 times 10 to the minus 2 meters. Or we could replace this scientific notation by using a different prefix. And so that's really what we use these prefixes for in scientific notation and the scientific method, and the SI units. So that's what we will be using a lot. And you want to make sure that you're paying close attention to your units and doing conversions if necessary. There is another way to convert, but we will talk about that when we do dimensional analysis with different kinds of unit conversions. For now, this should be enough to get you started with the metric system and scientific notation.